In this lesson, we're going to talk about how we can solve triangles using the sine law and the cosine law. So when we have a right-angled triangle, so we know that that's a triangle that has a right angle in it, there's a few tools that we can specifically use for these type of triangles. And those tools are SOHCAHTOA. Those ratios, sine, cosine, and tan, they're only going to work with right angle triangles. And the other theorem that we can use is the Pythagorean theorem. A squared plus b squared equals c squared. And we know that that only helps us to find side lengths. So what if we don't have a right angle triangle? What can we use? Well, that's where sine law and cosine law come in handy. Sine law and cosine law will work for all triangles, including right angle triangles. However, 99.9% of the time, if we do have a right angle triangle, SOHCAHTOA and the Pythagorean theorem are going to be much faster than sine law and cosine law. So we typically use these tools when we have a right angle triangle, but when we don't, we can use the sine law and the cosine law. So here's what the sine law and the cosine law look like. The sine law is a bunch of ratios, and the cosine law are three different equations that look very similar, just with some changes in letters. So as we can see, sine law and cosine law, it doesn't use opposite, adjacent, hypotenuse like SOHCAHTOA does. It uses the letters A, B, and C. And so A, B, and C come from these triangles, and notice, or this triangle here, and notice that it's a combination of small a and big A, so lowercase letters and the uppercase letters. So typically we use uppercase letters to denote angles, and sine law and cosine law just automatically labels them A, B, C. So the most important thing, you can put the angles wherever you like. You could have made this one A and this one B and this one C. The most important thing is the side lengths. Where you choose to put your angle tells you what the opposite side length is going to be. So if we chose to put our big angle A out here, as a reminder, uppercase letters are always used for the angles. Across from it would be side little a. So uppercase for angles, small lowercase for side lengths. So here's angle A, across from it is side A. And then for B, here's angle B, across from it is side B, and angle C, across from it is side C. So once you have your triangle labeled, you are free to use sine law and cosine law. The question is how to use them and when to use them. So we're going to start off with sine law, and we're going to learn some tricks as we go through sine law, but generally what I do is I always start with sine law first because it's generally faster, and then try cosine law if I don't have enough information. So I'll teach you a trick as we go through this video. But this is what we need to learn. We need to be able to find a side and an angle using sine law, and we need to be able to find a side and an angle using cosine law. So those are 4 examples that we're going to try. Okay, so let's start with this first guy here. I can see it's a non-right angle triangle, so I cannot use SOHCAHTOA Pythagorean theorem. And it asks to solve for side P in the triangle. So I'm just going to circle this guy. Okay, so I haven't shown you when to use sine law, when to use cosine law yet, but I did say that I generally like to start with sine law first. So let's teach you how to use sine law before I can go over when to use it. So first step with sine law is just write it out. So I'm going to write out side A over sine of angle A, side B over side of angle B, and side C over sine of angle C. Okay, step number 1, write it out. Step number 2 is label. So instead of using opposite, adjacent, hypotenuse, we're just going to use A, B, C. And we're going to start with the angles first. So you can put your angle A anywhere you like. Maybe you choose this one is your angle A, and this one is your B, and this one is your C. The most important thing is the side lengths. Across from the big letters is the corresponding side. So if this is angle C, then this would be side C because it is all the way across from it. This is angle A, then this is side A down here. And our leftover must be side B. So step number 1, write out sine law. Step number 2, label your triangle using the A, B's, and C's. Step number 3 is fill it in. So do we know little a? Little a, yes, we know it's 21 over sine of big A, angle A, which is 95. Keep going. Little b is, we don't know it. And then sine of angle B, we don't know it, equals side C, we don't know, but we know we are looking for P. I'm just going to replace it with P. And then sine of angle C, which is 32 degrees. So we have everything filled in there. However, we could have actually filled in something else here that we can find, which is side B. I said we didn't have it, but we can find it because we know that all the angles in a triangle have to add to 180, and we know the other two angles. So we can just find side B by taking 180 minus 32, take away 95. And we have the answer of 53. So I'm going to erase that we don't have side B here, and we're going to replace it with 53. Okay, so next step of sine law, we filled it in, we right now have 3 ratios. We just need 2. We need 2 to make an equation. So the 2 that you pick, one of them has to be complete, so no missing variables, and the other has to have the thing that we're looking for. So in this case, we're looking for P. So I need to pick the ratio that has P in it. That's going to be this one. So that's going to be one of the ratios we choose. Has to have the thing we're looking for. And the other ratio has to be complete. Now, which one of these is complete? This one is. So these are the 2 ratios we're going to pick. So one has to be complete. One has to have the thing that we're looking for. And once we have that, then we're just going to rewrite them in a new equation. So I'm going to write, we've got 21 over sine of 95 is equal to P over the sine of 32. Now we're just solving for P. So to get P by itself, I have to get rid of this divided by sine 32. And the opposite of dividing by sine 32 would be multiplying by sine 32. So I'm going to multiply on both sides. Sine 32 divided by sine 32 will be 1. And into my calculator goes the following. Make sure that your calculator is on degrees. All of these angles are in degrees. We're going to put sine of 32 times 21 divided by sine 95. Actually put this in the calculator to make sure that you get it. Sine 32 times 21 divided by sine 95. And you should get 11.17 approximately. Is that a reasonable answer? Let's take a look at the others. Yeah, that seems reasonable. It's not to scale, but this seems reasonable to what we were given. And we're done. So now we know how to find a side length using sine law. So let's figure out how to find an angle using sine law. I still haven't taught you how to tell if you can use sine law or cosine law on a triangle yet, but that is coming. So I'm just going to tell you sine law is going to work here. So let's go through the exact same process that we went through before. Step number 1 is write out sine law. So let's do that first. Step number 2 is label our triangle with A, B, and C. So here we go. I'm going to choose, it doesn't matter, remember it doesn't matter, but I'm going to choose this one as my A, this one as my B, this one as my C. What matters is the sides. Across from angle A is going to be side A. Across from angle C is going to be side C. And the leftover is going to be B. Across is B. Let's fill in what we know. And before I do that, is there an angle that I can find just like last time? In this case, we're missing 2 angles, so there's not a way for me to fill in anything that I'm missing here. So let's start filling this in now. Angle A, side A. Let's see what we have here. Angle A, side A. We don't have angle A, but we can call it X, and side A is 60. So when we fill it in, we're going to say our side A is 60 centimeters. Sine, instead of A, we can put angle X equals, let's do the same thing for B and C. for B, we don't have side B and we don't have angle B, but we do have side C, it's 100, and angle C, it's 125. So let's fill this in. B, we don't have side B, we don't have the angle B, but we know that side C is 100 and sine of angle 125, that's what C is. So just like last time, we are going to pick two of these ratios. One of them has to be complete. One of them has to have the thing that we're looking for. This case, we're looking for angle X, which happens to be what we called angle A. So this is one of the ratios we have to use. And the other ratio has to be complete. And in this case, this guy's the one that's complete. This one is incomplete. We don't have either of those. Next step is to rewrite them as one equation. So we have 60 over sine x is equal to 100 over sine of 125. So now we're stuck trying to solve for x here. This is a little different than above what we had going on here, because when we had our equation here in this previous example, the letter we were looking for was at the top of the fraction. So here, this one's a little different when we're finding an angle for sine. What we're looking for is at the bottom right now. So we got to get to the top. So we can do a trick called cross multiplication. You can only do this trick when we have one fraction on one side and another fraction on the other with an equal sign in between. So fraction, fraction, equal sign, nothing else. Then we can do this trick called cross multiplication, where we multiply from the bottom up and from the bottom up here. We literally cross and multiply. So here's what's it's gonna look like. This one is going to say sine x times 100. Sine x times 100. So I'm going to write sine x and then times 100. Here we go. And on this side, I'm going to say sine 125 times 60. So I'm going to write sine 125 times 60. So we're just crossing and multiplying, crossing and multiplying. So now at least x is on the top. Now we got to get it by itself. We know we can get rid of that 100 by dividing by 100 on both sides. We know that that's going to go away. Please do not throw this into the calculator yet. We want to only use the calculator one time so that our answer is as exact as possible. So do not put this in the calculator just yet, because x is still not by itself. How do I get rid of sine? I know I'm going to have to apply sine inverse. So I'm going to take sine inverse of this entire left side. So we have the sine of 125 times 60 all over 100. And that's what's going to equal x. So we took sine, brought to the other side, sine inverse. So we're going to put this all in the calculator. Make sure that you put brackets, sine inverse brackets, and then put this all in. And make sure that you get the right answer. You should get approximately 29.44 degrees. If you didn't get that, try again, paying close attention to brackets. Try a few more times, and if you still don't get it, make sure that you come and talk to me very quickly so we can figure out how to use your calculator. So we now know how to find a side length using sine law, and we now know how to find an angle using sine law. So now let's practice using cosine law. So this question gives us another triangle and we're finding another side length. So I haven't shown you yet when to use sine law, when to use cosine law. In general, sine law is typically faster than cosine law. So I always like to try sine law first. So let's actually see if sine law is going to work here. And we're going to come up with a rule together to figure out, just by looking at a triangle, how can you tell if sine law will work or not. So let's first try by actually writing out sine law. Now that we have it written out, let's just label this guy really quickly. Because this is my angle, or side B, I'm going to make across from it angle B. It just works out nicely. Maybe I'll make this guy A and this guy C. So I'm going to quickly add my notes here. And now let's fill in Now that we have labels and all of this, let's fill this guy in really quickly. So side A, do we have it? Yes, it's 16. So let's fill it in. Instead of little a, we're going to put 16 over sine. Do we know what angle A is? No, it's blank, so leave that guy alone. Side B, do we know it? No, and we're also going to call it side B, so we're going to leave it. And then sine of angle B is 52. Just a reminder, we are looking for B. That's what our goal is. And then sine C. So do we have side C? Yes, it's 20. Do we have angle C? No. So when we're using sine law, we got to pick two ratios. One that's complete, one has the thing that we're looking for. So here's the thing we're looking for. Which ratio is complete? This one? Nope. This one? Nope. This is when you can't use sine law. When you don't have a complete ratio. Now you don't need to write this all out to be able to figure out if you can use sine law or not, because you can just look and check if you have a matching side and angle. If you have a matching side and angle, then you will have a complete ratio. So you can tell just by looking at the triangle if you can use sine law or not by checking if you have a matching angle and side. So here we have an angle, no side. Here we have a side, no angle. And here we have a side, and again, no angle. So very quickly we can tell this is not a sine law problem. So here we can check really quickly. Also note that when you are checking if you can use sine law or not, fill in any of the missing sides or angles that you can find, like we did here. So taking a look here, taking a look here, 32, we have angle, no side, but here, angle and a side matching. That's how we can tell really quickly if we can use sine law here. So back to our question here, we can't use sine law, therefore we have to use cosine law. So cosine law works the same with sine law in that you have to label the triangle. And once the triangle is labeled and you figure out which side or angle you need, you're going to go to cosine law and pick which of these three equations you're going to use. So consider these like three different options. Here's one, here's two, here's three. And we're looking for side B, so it's little b. Which of these equations would be best to find little b? Well, I see b's here and b's there, but not helpful. Look at this equation though. B is already isolated for. This equation will help us definitely find side B. So I'm going to copy it down onto our question. So here we have the equation that we chose copied out. Let's start filling it in. We don't know what side B is, so we're going to leave that alone. Let's see, what is our side C and A? So C is 20 and A is 16. So instead of C squared, I'm going to put 20 squared. Instead of A squared, we can put 16 squared. And then we're just going to keep filling this in here. This is minus 2, C is 20, A is 16, and then cos of angle B. And we know that angle B is 52 degrees. So we're going to fill that in. I know that we made the right choice using cosine law because everything is filled in here. We only have one unknown. So we can throw this entire thing in the calculator at once. One note though, B isn't quite by itself yet. We need to get rid of the square root. So we're going to square both sides. We do not need to put a plus or minus in front of the square root because B is a side length and length can only be positive. So there's no need to put a plus or minus in front. So right into the calculator, we're going to do all of this and take the square root of it. And let's make sure you get the right answer. And you should get approximately 16.19, and what are the units here? Meters. So now we know how to know when we can't use sine law and we have to use cosine law. And we now also know how to find a side length using cosine law. So our last one is finding an angle using cosine law. So let's say I didn't tell you to use cosine law. How could you tell this is not a sine law question? Well, we don't have any angles here, so there can't be any matching angle and side combinations, which means cannot use cosine law. We have to use, we can't use sine law. We have to use cosine law. So here we go. Let's fill in, let's label these angles and sides. So since this guy is angle A, let's make the bottom one side A. And then maybe we can make this one B, and this could be side B, and this one C, and this could be side C. So we're looking for angle A in this question. So when we are using cosine law, we got to pick which equation is going to help us find angle A. So here are the possible cosine law equations that we could pick from. Which one can we use to find angle A? Well, this is the only place that the angles appear in these equations. So this is the only equation that has angle A in it. So we're going to go and copy equation number 1. So now that we have that equation copied, let's start filling in what we know. We know that side A is 30, so let's fill that in. Side A is 30, so instead of little a, we're going to write 30 and then squared equals. Do we know side B and side C? Yes, B is 26 and C is 38, so let's fill that in. 26 and 38. Okay, so let's keep on filling it in. Next we have -2 times B is 26, C is 38, and we don't know angle A. That's what we're looking for. So it's going to be so tempting to throw this all into the calculator just like above. But let's just zoom out here. Can you see the difference between what we did in the previous example versus here? The previous example, the letter that we're looking for, in this case was a sine length, was already isolated for. So these were all just constants we were adding and subtracting together. Here, the letter that we're looking for is not isolated. We have to isolate it, which means these are not all like terms. So we're going to, instead of putting it all into our calculator at once, we're going to calculate these one at a time so that you can carefully see what the like terms are, so we don't add and subtract something incorrectly. So this is what each of those terms separately is equal to. So 30 squared is 900, 26 squared is 676, etc. Then we just multiplied -2 times 26 times 38, and that made -1976. And then we have this cos A here. So which numbers here are actually like terms? This one has an A attached to it. No other term has a cos A attached to it, so this is not a like term to anything here. These three are like terms. So we can add and subtract these three together. So I'm just going to, because they're already on the same side, I'm going to add these ones together really quickly. Okay, so I added these ones together and I got 2,120. Let's get A by itself now. So I'm going to collect these like terms. I'm going to bring this 2,120 onto the other side. So we've got 900 minus 2,120 is equal to -1976 cos of A. If I subtract these guys now, I'm going to get -1,220 is equal to -1976 cos A. So we're getting closer at getting this A by itself. What do I have to move next? Well, I can move this times this number here. I can move that. I can move the multiplication of -1976. I can get rid of it by dividing by -1976. And we're going to do the same thing on both sides. So this will work out to 1. On the right side, we're just going to be left with cos A. And on the left side, this is not going to be a pretty number. Leave it. We only want to use a calculator one time at the very, very end, so that we can have a most exact answer as possible. So please don't put that in the calculator yet, because we still have one last thing to move, which is the cos. How can we get rid of cos? What is the opposite of cos? It's going to be cos inverse. We always have to use an inverse function when we are finding an angle. So I'm going to take the cos inverse of everything that was on the left side here. And now we have a by itself. So all into the calculator all at once, we're going to put this guy in. So it's going to be the cos inverse of negative 1,220 divided by negative 1976 and the bracket, and see what you get. Did you get approximately 51.87? And that's going to be in degrees because we were looking for an angle. If you didn't get that, carefully make sure that it looks like this in your calculator. Try it a few times. Reach out to me if you're still not getting it. So what we just did is we did 4 examples. We did 4 examples, 2 of cosine law, finding a side, finding an angle, and then 2 of sine law, finding a side and finding an angle. And we're done.